So external agent will pull out the slab. I'm asking all the things. What about each generated? All queries like earlier we did. Can you remember yesterday we did know like some external agent pulling the slab or increasing the separation between the plates. Here, let me pull in. Let me pull out. Let's get into the concept. So external agent and external agent pulls out the slab from capacitor, from above capacitor, will write. From one of the, from capacitor, then find it generated in circuit. We are again coming back to same idea of heat generated. Before pulling out, we need data. Am I right? After slab brought out, then the data. We'll compare both, then we can analyze. Otherwise, not possible to say anything about the conditions in the circuit. The one which is pulled out, I'll keep it here. Okay, the slab is brought. Who is going to bring that slab? External agent. Then how much capacitance will become? With slab, capacitance was 4 farad. Now after removing that, it will become 2 farad, no? C1 dash, you write it better, justified. Let's get into the calculation part. So earlier there was a charge, say Q. This charge will call capital Q. Comparisons will be easier. We have to calculate that charge. Okay, you can apply anything. So better let me stick on to the loop equation so that I'll not go wrong. Minus Q by C1, Q by C2. E is 10, Q we don't know. This is 4, this is 2. 10 equal to, this will be 1 by 4 plus 1, 3 by 4. 3Q by 4. 40 by 3 coulomb. I think we'll bring any some. Yeah, let it be. So there's the initial charge. Okay, final charge will calculate. Final charge will be E minus Q by C1 dash, Q by C2 equals 0. This is 10. Both are having same capacitance 2. This is 2. 40 by 3. What is 40 by 3? Greater than 10. Q 10 coulomb. So I think a small, some idea we have now. Look at this plate, this particular, any one plate you look at. The charge on this plate increased or decreased. Earlier it was 40 by 3. 13.33 coulomb. Now it is 10 coulomb. So some charge left from here and the positive charge entered positive terminal. So we are able to now predict the work done by the cell. Okay, fine. So what was our query like? Heat generated in circuit. So what to do for that? Because here some extra agent also is there in the picture. How to take care about him? Say extra agent will spend energy first of all. As it starts pulling out, the plates of capacitor will exert force towards left. So he has to overcome that force. So his mechanical energy got decreased. So that energy, where do it will go? He will supply, he will give energy to the system, or he will draw energy from the system. Now, some of the I want from students all this because these are very beautiful ideas. The students' replies are matters a lot. Anybody wants to reply? How, yourself only. You are going and there. What you're doing, you're just pulling out the slab. You lose energy. Where do your energy will go? Who will take this energy? agent gives energy to system. Yeah, that's what. X-ray agent will give that energy to the system. And what is the system here? The overall, like will it give energy to the cell? No, altogether the system here. And how to bring that work done by X-ray agent? I think we had earlier discussion very clearly. Work done by X-ray agent should be equal to what? Mod of delta U. So whether it's increasing or decreasing, let it be mod of delta U. So again, we'll enter into our old method. The first method, what we brought it, the initial energy plus work done by cell, work done by X-ray agent equal to final energy plus heat generated. We'll solve for H. So first we have to calculate that initial energy. UI equal to Q square by 2C1, Q square by 2C2. Q is 40 by 3. I think C1, C2, we can simplify. 1 by 2 plus 1 by 4, 3 by 4. Instead of squaring this one, then Q square will become 40 by 3 whole square by 2 into 3 by 4. 1, 3 get cancels. Here 4, 10, 400 by 6. 200 by 3. I'm not sure whether I'm correct. You have to verify it. And now final energy will be equal to again similarly here Q square by 2C1 dash. It's a test of patience because we know concept, but unless the data is there, we can't conclude. Q is how much? 10. Okay, this again will be 1 by 2. It will become only just only Q square by 2. So this will become 10 square by 2, 50 joules. Look at anybody says UF is less than UI, no? The potential in the circuit got decreased. X-ray agent also did work. Where do all gone? Work done by cell heat generated. Is it heat generated? Is there? Yes, we don't know, but we have to calculate here. So I'll proceed here now. This one, UI. I think there's a. I'll indicate by red color. This will be UI. Work done by cell. Work done by X-ray agent equal to UF plus heat generated. So I'm telling this one, the electrodynamics by IEDO. Don't go and read again because already explained. Say there's a major problem with the student. When we say some book, no, then again students will think if you read that book, you can solve any problem. To solve any problem, again, you have to put effort. So don't be in a perception that there is some book. If you read that, you'll get a knowledge. Just in the one of the paragraph, he has mentioned very systematically. In all capacitive systems, if an X-ray agent comes and modifies the capacitive system, and if an energizing agent is also an energizing electrical agent is also present, you mean to say cell, then use this particular thing. It's a golden statement here. See, there's a beauty of that books here. So many students will say, sir, no problems, nothing, only story is there. In one of the paragraphs I just mentioned, just like in a capacitive system, if an X-ray agent modifies a capacitive system, and also there's a energizing system is there. Energizing means cell, that one. It can be anything. Here I brought a cell. There can be in any way I can bring the energy, no? You just put energizing cell. So then use this particular formula so that energy will be conserved. Finish over. I think we have some around 60, more than 100 numericals are there, just revolves around that statement. Okay, now we'll substitute all these things. We'll 200 by work done by cell. We don't know that, what to do. So I look at this particular plate. Let me take only one plate rather than this one. Any one plate is enough. The plate which is connected to positive terminal of a cell. I am bothered about only this plate. Look at this plate. What was the initial charge? The initial charge was Q, 40 by 3. Final charge is 10. So some charge left then it has become capital Q. So that the charge left is, let me show it here only. Now delta Q into E. Positive charge entered a cell, so therefore I'll put negative. So what you calculate delta Q, charge left, no, charge left should be negative. How to calculate delta Q? Again, we will take the thing that one. Initial charge was Q, charge left delta Q, or it is like this, no? And it has become finally Q. So 40 by 3.
10 by 3, sir.
How much delta Q?
10 by 3, sir.
10 by 3 coulomb. Okay, this will be 10 by 3 coulomb. Now work done by X-ray agent. What to do? Again, we don't know work by X-ray agent. Should be mod of delta U. Will it be positive or negative, sir? What will be that? I think first we'll work out few these things, then I'll go for substitution. We'll calculate these things also. UF is 50. That is 200 by 3. Uh, 150 minus 50 by 3. So take it 50 by 3. Now we'll bring all the things here. Sir, it should be negative. You took mod, so better you substitute negative sign. How to justify? So will you give priority for mass, or really some physics is there which has to be taken care? See, to pull this slab, when I'm pulling this slab out, the force will act towards left, no? Then there'll be capacitor will exert force. I should overcome that force, so I should spend my energy. This what here. Equal to final. Finally is how much it is? UF of 50 plus heat.
The heat is 0, sir.
It is 0. Yeah. Delta Q into E. 10 by 3. 10. So no heat is generated in circuit. See, some 100, 200 years back, this was maybe like they proposed long back. You see, so much of visionary, the Western science. How to get electrical energy, because this is something, this electrical energy is something very useful for us, no? And what is available for us? Mechanical energy. So can we convert our mechanical energy into electrical energy? This is a system. So now we are at a stage where we are able to convert this mechanical into electrical energy. This was the ideas. Some 100, 150 years back, they have brought all these things and they made students to learn so that future generation can design equipments which can convert mechanical energy into electrical energy. 150 years back, they have thought, just imagine like how much of visionary they have. Many will say, sir, why you appreciate so much? You see that all these are not numericals. The scientists or the students or the teachers who are there, no, the authors who are there, no, they wanted to impart the knowledge so that will be useful for society. They brought that as numericals. If I make numerical, no, it becomes stupid numerical, no doubt. So what all we have numericals till date, it was all 99.99%. All the numericals are having some meaning. Some numericals may not be practically possible, but coming generation, after 500,000 years, we may work out. So this is the power of all this numericals here, especially physics. No, it's about the numericals are not just like some mere question answer. Everything what happen will be implemented practically, if not today, tomorrow. Now we have electrical equipment. You type in Google, no, you have equipment, but little bit they're costlier. Maybe technology improves, they'll become cheap. And then in my home, what will happen? I can generate electric power. I need not to depend on government. Government of India. This is what they're planning future. No, please do work out almost, I think, slabs, everything. Tomorrow, one more set will go for it. Still more conceptual questions on the dielectric slab is what I have to discuss. And there's, I think you check the advanced paper, there's some sort of priority as given in capacitors with the dielectric slabs. He has given some priority. So better to work out some best numerical so that will be in a safer side. Yeah, I'll wind up the class. Thank you, all of you. Post office box, I'll explain on Friday, very simple, half an hour it is, meter bridge only it is. Or I'll post the video.